day 24 of geometry, and today is Thursday, November 13th today. So for your do now, I gave you 4 circles with either a radius or a diameter, and I wanted you to find the area and the perimeter of them. And I gave you a challenge problem that we'll look at the end. So, for number 1, is this a radius or a diameter?
It's a radius.
It's a radius. Okay, so first I'm actually going to put to the side, what are my area formulas?
Pi times radius squared.
Yes, or formula, there's only one. Pi radius squared. Okay, and then my circumference formulas. There are 2 of these.
There's 2 of them.
Okay.
One is 2 times pi times radius.
Good. So 2 pi radius. What's the other?
Pi and times diameter.
Perfect. Pi times diameter. So those are our formulas. So I know I have a radius. How do I find my area?
I take pi times 5 squared.
Perfect. Pi times 5 squared.
They give you 78.53 inches squared.
Okay, so again, to find pi, we hit second and the up arrow above the division symbol. There's pi. 5 squared is the x squared button. Enter. And that is our answer. 78 point all around to 54. 78.54. What are my units?
Inches squared.
Inches squared. So 78.54 inches squared. Okay. And circumference. How do I do that?
It'll be 2 pi radius.
2 pi times radius. We can use that. Good. 5 again. So 2 second up arrow pi.
Should be 31.41 inches.
31.4. I'm actually going to round that up to a 42. 41 I would still accept. That's just fine. But I'm going to put it as 31.42. 31.42 units are inches. Good. Good. Okay. Very nice. What do we do on that one? You get it?
The second half.
The second half. Do you know what you did wrong?
I just did it.
Oh. Okay, I got you. Just didn't finish it. That's okay.
I just.
You're okay.
I wasn't here today, so.
All good. So we have number 1. Let's look at number 2. Now I'm given a length of 12 inches. Is that a radius or a diameter?
The radius.
That's a radius this time again. So let's start with our area. And what will I type in my calculator?
Pi times 12 squared.
Pi 12 squared. So I'll type that, pi 12 squared.
You get 452.39 inches.
Yes. 452.3, we'll round up to 9. 452.39
Inches squared.
inches squared. Good. 452.39 inches squared. Good. Okay. Circumference. So, how could we find the circumference?
You take 2 pi and times your 12.
2 pi radius 12. Type that in. 2 second up arrow 12.
Good. You should get 75 75.40 inches.
75.40 inches. That's what we'll round. If you put 39, I will not count it wrong. That would be just fine. 75.40 inches. These go pretty quick. Perfect. Okay, that was number 2. Number 3 and 4, very similar, just ever so slightly different. A couple people still copying this down. I'll wait just a second. Let's go see those. Okay. Number 3. Now I am given a measurement of 52 inches. What measurement is being given here?
The diameter.
The diameter. It's all the way across. So now we have a diameter. So if I want to find my area, what will I need to do first?
Do your circumference equation first.
You could do your circumference equation first. You absolutely could. But let me ask you about area. If I want to find my area, I can't use a diameter, can I?
You
I
gotta
gotta
divide
use
the diameter
radius.
by 2.
Yes, so we need to divide this by 2, and that will give us our radius. So I'm going to write here R equals 52 divided by 2, which is
26.
26. So radius is 26. And now we can find our area. So what will I type to find it?
Pi times 26 squared.
Good. Pi times 26 squared. So second, pi 26 squared. 2123.72. We'll round up. 2123.72. Good.
Inches squared.
Inches squared. Now we have our area. When we do our circumference, since we have both the diameter and the radius now, we could use either formula. Let's use the diameter one. What would I type in for that?
The 52.
Yes, pi 52, because our diameter is 52. So let's type that in, pi 52. And we get
63.36.
yes, 163.36
Inches.
inches. Yes, inches. Good. Okay, and last but not least, for number 4, do I have a diameter or a radius?
Diameter.
Diameter. Okay, so same thing we did last time. What do I need to find first?
The radius.
A radius. And how do I do that?
You take 21 divided by 2.
Yeah, divide my diameter by 2. So 21 divided by 2 gives us
10.5.
10.5. Okay, so now I have a radius of 10.5. Let's find the area.
You're going to take pi times 10.5 squared.
Good. Pi radius squared, so pi 10.5 squared. Okay, so I'll type that in. Pi 10.5 squared.
You get 346.36 inches squared.
Perfect. 346.36 inches squared. Okay. Equals 46.36 inches squared. And last one, circumference.
It's just gonna be pi times 21.
Yeah, pi times diameter, which is 21. So pi 21.
You get 65 point, if you want to round it up, 98.
You do get 65.9. Actually, this one, oh, okay, here we go. We have 65.97. Is the number after 7 5 or bigger?
No.
No, so we actually don't have to round this one up. Leave it as 97. 97. We only round up if the next number is 5 or bigger. But again, I won't be picky as far as grading goes. So, circumference. 65.97 inches. Okay, so that's our 4 circle problems. And I will pause just for a moment, let everybody catch up on that and ask any questions if there are any. And then in just a moment, we're going to go down to that challenge. So let me just pause this. Give me a thumbs up whenever you are ready to move on. So I have told you that we have a circle with a perimeter of 49 inches. And I want you to find the radius. So, does anybody have an idea of where to even start on this?
I do.
Okay, go ahead.
You can take 49 by 2
Divide by 2? So why do you want to divide it by 2?
because the perimeter is the same as
The same as the what?
circumference.
It is. So perimeter is circumference, and really that's the word I should have used. Circumference. Okay. So I know perimeter is the same thing as circumference. And so knowing that that is circumference, where does dividing by 2 come from for you? Like, did you set up a problem and divide by 2?
Pi by pi
Why?
is pi times the radius.
Okay, that's what I was looking for. So both of you are correct. Both of you are correct. But what we want to think about is where are these numbers coming from? So we're going to bring down the circumference formula for a minute. You know that that is 2 pi r, right? So if the circumference is equal to 2 times pi times radius, and the circumference is equal to 49, what if I say these are equal to each other? Because they are. This is my circumference. This is my circumference formula. Now we have radius that we can solve for. So this is sort of the equation we'll set up. 2 pi radius equals 49. Now here is where we can see why we're going to do what both of you said to do. You're both right. So Jess, you said let's divide by 2, right? Let's do that. We want to get radius by itself, so we will divide by 2. Divide by 2. Okay. That gets rid of these 2's. And then what would come down?
The pi.
Pi and radius come down equals
24.5
24.5
inches.
inches, yes. And now this is where we go to Jaden's idea because we still don't have the radius by itself. So this just means pi times radius. Let's divide by pi to get radius by itself. Which will cancel it. Bring down radius is by itself, and 24.5 divided by pi What do we get?
80
Yes, 7.80
inches.
inches. Now, it wouldn't be squared unless it's an area. This will just be inches since it's measuring a length. And that is our answer. So, yeah, you guys were right. This is just a more certain way of doing it so that we know why we're dividing by 2, why we're dividing by pi. Comes from that formula there. So, very nice. Very nice. That makes sense to everybody?
How do you get the 7.8?
We did 24.5 divided by pi. So when I type that in, 24.5 divided by pi, you should get this on your calculator. 0.5.
Per second?
After you divide, so it's 24.5 divided by second up arrow to get your pi. Mm-hmm. And then your second up arrow.
5.
Yes, pi. Enter. You get that? 7.798522 or 92212. Hey. Good work, you guys.
Okay, so Taylor, I have a question. So, like, because of the way that I did it, it was, a little bit different and everything. It's still valid.
Still valid, still correct. So Kelsey did it in a different way. Kelsey did, let's see. What did you end up writing? You
I ended
put
up, R equals 49 over 2 pi.
over 2 pi. So basically what you did is you divided by 2 and pi all at the same time.
Yeah.
Which that works. We can do that. As long as we make sure that this is happening kind of first.
Right.
Because if I type in my calculator 49 divided by 2 pi, my calculator is going to do 49 divided by 2 first, and then it's going to multiply times pi.
See, yeah, like in that situation, it goes back literally to PEMDAS.
Yeah.
Take care of your.
Yeah. Literally.
Yeah.
Awesome.
Okay.
Yeah, so this is the same thing. Very nice. Very nice. Okay, guys. So what we're gonna do today is we're gonna learn one more thing about circles. And this time, rather than looking at sort of these lines and distances and areas in circles, we're gonna start talking about angles in circles, which all of you should have that worksheet I passed out. Let me grab my copy. Looks like this. Arcs and central angles. So just have that out to the side. And before we get to it, I am going to have us take a couple of little notes. So before I take out my notebook, does anybody still need this? Can I move it? That over. And let's take some notes. The title, my page. Let me actually put it in the right notebook here. Set my notebook down somewhere. Where did I set it? It is. All right. So, let me. And again, it is day 24, so these are our day 24 notes.
It's still unit 4.
Yes, still unit 4. And we are going to title this page with the same title on our worksheet, arcs and central angles. So, A, R, CS arc and central angles. So, also going to draw a circle below this title. Draw a circle. And then we're going to put a point close to the center as we can. Probably be about right here for mine. I'm going to get the ruler out. Here's what I want you to put in your circle. We're going to start with a line that goes straight up and down through the center. You're drawing a diameter. Then you'll draw another diameter going across this way, forming a 90-degree angle for all four of your angles. Let's put a little box in one of our angles. Yes. And then what we're going to do is we're going to label all of these with they'll be kind of like little points on the circle. We're going to give them letter names. So I'm going to go with A, B, C, D, E. Yes, E is the middle point. So if this angle here is 90 degrees, first of all, let's make sure we know how to label angles in a circle. We have a 90-degree angle here. And the way that we label angles is we take these outer points, and they will be the outer points of our label. The vertex or the point of the angle goes in the middle. So we would label this as angle B, E, C. Angle BEC. BEC. That is 90 degrees. Now we've learned about angles plenty this term, but something that circles have that is a little bit unique, no other shape that I know of really has these, are the arcs. So arcs are just the curve that is kind of inside of that angle, right out rounding the edge. And we name arcs with degrees, just like we do angles. What's really nice about arcs and angles is they're the same. This is how we name them though. So this arc I've just highlighted here, we would name just like we would a line segment, point B to point C, so it's BC, but instead of drawing a line over the top, we draw an arc. And because the angle inside of the arc is 90 degrees, we also can say the arc is 90 degrees. If this angle is 90 degrees, angle BEC, do we know the measure of any other angles in this circle? We do. What do we know?
They're all 90 degrees.
They're all 90 degrees. The reason for this is right here we've got opposite angles, vertical angles, so they must be equal. So that would mean AED is also 90 degrees. And if I know that these angles are forming a straight line here, it makes 180 degrees. So the other one's got to be 90. And then that's opposite, so that's 90. They're all 90. So if all four angles are 90 degrees, how many degrees are in a full circle? 360. So a full circle, right? Full circle is always not 100, sorry, 360 degrees. This is an important thing to know. Very important to know. It may also be good to remind yourself that a half circle is half of 360, which is how many degrees? 180. So these are the main sort of notes that we're going to need today. And we will use this to help us on that worksheet I've given you. We're going back to solving angles. So let me pause for a moment, leave that up, let you guys write that down, and then we're going to look at the worksheet. Okay, so looking at our worksheet and thinking about all of these things that we've just taken note of, we're going to look at number 1. First of all, our instructions say, find the measure of the arc or the central angle indicated. Assume that lines which appear to be diameters are actual diameters. The reason we say that is because if you see a line that goes all the way across the circle, you need to know that that is a diameter. So it splits the circle in half, giving us 180 degrees on both sides. So looking at number 1, it says we want to find GJF. So where is GJF?
What is M?
Oh, let's talk about that. M just means measure. So they're asking you to find the measure of angle GJF. What I'm going to do is I'm going to highlight those letters. Measure of GJF. Here's G. Here's J. Here's F.
66.
Right away, you got it. This is going to be 66 degrees. So we're talking about this angle here. We don't know it, but we do know that this one is 66.
And it's right across.
And they're opposite, they're vertical angles. So if this is 66 degrees,
Or that.
that is 66 degrees as well. Not so hard. So what we can say is angle GJF is 66 degrees. Here we go. Let's look at number 2. Now I want to find the measure of the angle labeled SQT. So let's label S, Q, and T. And I'm going to highlight the lines that make up that angle. What do we know?
Isn't that angle above it is
Yes,
90 degrees?
There's a 90-degree angle. Both of you are right. So it looks like RQS, because of this box, is 90 degrees.
And it's mirrored on the bottom.
And it's mirrored on the bottom. I know that since there is a diameter here, this is 180 degrees.
So it would be
Yes, 90 plus 90 is 180. So this also has to be 90. Good. So my answer is angle SQT is 90 degrees. Awesome. Won't be? Yes, you're right. It will get harder. It will get harder.
Doesn't know, like.
It does. Okay, so how about now? Number 3 looks like it's going to be just like those last two. Pretty simple stuff. Or will it be? Let me check. Check. No, it will be a little bit different. Okay, let's look at that, number 3. So moving down, let's look at number 3. Now it says we want to find the arc, IJL. So we want to pay attention to the symbols. Now we're finding an arc. So I am going to highlight those letters, IJL. IJL. And we want to show the arc based off of the letters they give us. This means we're going to go from I to J all the way over to L. I, J, we're going to go all the way through K to L. So this wants to know, what is the measure of this arc?
Subtract 109, get 360.
Yes, I know a full circle is 360 degrees. I know 119 degrees of the circle. I want to know the rest. So here's what we can do. I know that 119 degrees plus IJL equals 360. So we're going to do exactly like what you said, Jaden. We just got to solve for IJL. We'll subtract 119 from both sides. Of course, you don't have to set it up like an equation. You could just know, okay, I'm going to subtract 119. But if it helps you to do this, sometimes extra steps can keep you a little more organized. So I'll bring down IJL.
241.
241 is what you got? Okay. Let's see. Double check it. I'm sure that's right. 50 minus 119. Yes. We did. 241 degrees. And so that's our answer. Too bad. Do we have any questions about how we did any of this one? That was a little different. Or does it make sense? Okay, I see some thumbs up. Good. Okay, let's look at number 4 now. We get a little more complicated. Now I have a couple of things being given to me. This time I want to find a measure, angle BHC. So let's find those. BHC. How can I find that?
The 71 and 43.
Yes, that's all you do. They already gave us this measure and that measure, and those are inside of that EHC. So we can just add them together. EHC equals 43 plus 71.
I got 114.
114? Yeah, that's right. Good. So angle EHC is 114 degrees. Good. Okay. I see you. A few more people still writing. Second. Let's see if we start getting a little more complicated yet. So we have some different things happening in number 5. First of all, want to find the angle FKI. So let's highlight what we're going to need. Okay. Trying to find this angle. I know that this angle here, FKJ, is 80 degrees. And then I know that this angle right here, JKI and IKH, these both have one arc in them. What does that mean? Equal. They're equal. These two angles are equal to each other because of that red arc. Okay? So, does anybody have an idea of what we can do here?
I think both of them equal 80.
Both of them equal 80, you think?
Yeah. No, the other one. The 80 degrees.
This one is 80 degrees,
Yeah,
yes?
and then both of them, they're 40, both 40, but they add to 80.
Okay, so what gives you that idea?
Because they look the same.
They look the same. So they do kind of look the same. But we want to make sure with math because sometimes drawings aren't accurate. You never know. It's a good idea though.
Add all of the other ones together.
Ooh, okay. So
Subtract it by 360 and then divide it by 2.
okay, so here's what we can do. All of my angles are labeled with something. I know that every angle in a circle added together is 360 degrees, right? So what if we try to solve for this whole thing first? And then if I divide that by 2, I can get just one of those angles because I just need one of those angles. So here's the equation I'm thinking of. Let's add everything together. 80, 60, 140, and for now we'll call this 2x since there's 2 of them. If there's an x here and an x here. So let's do 140 plus 60 plus 80 plus my 2 x's. And then all of that together equals 360 degrees. Do we see where this equation came from? We just added everything together. We gave those 2 angles the same name only because they have the same measure. That arc tells us that. So I have my equation. What would I do first?
Why do you like terms?
Yeah, let's combine our like terms.
You're 140 plus 60 plus 80 equals 280.
140 plus 60 plus 80 is 280.
Plus your 2x equals 360.
Good. Plus 2x, bring everything down, equals 360. What would I do now?
You take your, you minus 280 on each side.
It's 280 on both sides. Bring down 2x equals
80.
80. Elena, you were right.
I was just gonna say, girl, you were right.
You were right.
And
That's
you just
awesome.
divide by 2 and it equals 40.
Yes, divide by 2.
Very nice.
And we get that x equals 40. Okay, so that time, yeah, it was exactly what it looked like.
Yeah.
I will say that usually doesn't happen. So, always double check with math just in case. But we know now that x is 40. So I'm going to label both of those with 40s. Now that I know this angle is 40 degrees, how can I find the angle that I want to find, my highlighted angle?
Check out 80, 40.
Yes. Now we can just add the angles that make up the one we want. 80 degrees plus 40 degrees.
120 degrees.
Awesome. So angle FAI equals 80 plus 40. That is 120 degrees. Awesome. There we go. Good job, you guys. That one had a lot more steps to it, but it makes sense where those steps are coming from, right? Okay, good, good. Okay. You guys want to try number 6 on your own?
Yes, please.
Okay, try number 6 on your own. See if you can do it. I bet you can. Or at least try to get started on it. Try that one by yourself. I'll set a 5-minute timer, give y'all time to think. And when it's up, we will talk about our answer. Start. Okay, so looking at number 6. Can somebody tell me how they did it?
I've had them all.
Okay, you added them all together.
Yeah.
So did you write an equation?
Yeah.
Okay, tell me what equation you wrote.
I put 157
Okay.
plus 54
54
plus 45
plus 45.
plus 2x.
Ah, so you called this one x and this one x.
Yes.
So we put them together plus 2x.
Equals 360.
Good, equals 360. Okay, so I know that all of the angles add together to make 360. So what do you do next?
Combine your like terms, the 157 plus 54 plus 45.
Okay, 157 plus 54 plus 45. What does that give us?
It gives you 256
Okay, 256
plus 2x equals 360.
Plus 2x equals 360.
Do you subtract 256 from each side?
Good. Subtract 256 from both sides. 104. We get 104.
104, I got it.
So
2x
2x equals
104.
104.
And then you divide by 2.
Okay, divide by 2.
It'll be 52
You get x
equals 52
equals
degrees.
52 degrees. Okay, so at this point, we know that these two smaller angles are 52 degrees, so I'm going to label those. And let's pay attention to the angle that we need. We want the angle labeled SPU. So I'm going to highlight those letters. SPU. And I'm going to connect the dots. SPU. I want this angle.
You take 52 plus
Yes.
52.
You just add them together. Now, if you wanted to save a step, you could know from the start, maybe you have that highlighted and say, okay, well, I just need to know what those two are together. So when I get down here, what if we just didn't divide by 2? Because I know I'm going to use them both.
Right.
You could do that. You'll have that 104.
Yeah.
But that's okay. This is also a perfectly good way to do it.
Well, I did 52 plus 52,
Yes.
and it gives you 104 degrees.
Yes. 104 degrees is angle. SEU. Perfect.
Looks like a lot more.
Right. It looks like a lot more than it is. It does.
It's just you gotta put the pieces together.
Yeah. Yeah. Just putting those pieces together, remembering different things that we may know. I would like for us to look at, let's see. Can we look at number 8? Because that one is slightly different, but we're not going to use the full 360.
I'll just watch the video.
Okay. I know you gotta go. So on number 8, see you later. I want FDG. I like those. FDG.
EDG is the diameter,
Yes.
and so that means 180.
Ah.
Subtract 40 from 180.
Okay. You guys got it. So Kelsey just figured it out so quickly. This, because it's a diameter, splits it in half. That means we have a half circle here. This whole thing right here is 180 degrees. So, can't I just add 40 to that other angle and say that it equals 180? And then solve by subtracting that 40? Yes, we can do that. So, let's do that. 40 plus FDG equals 180.
So it's 40. You have to
Yeah,
add 40, which is
perfect. Get rid of 40. We'll subtract it on both sides. And so what is the measure of angle FTG? 140. Good.
they're all these ways kids.
I know, y'all are so smart. Yes. Love it. Love it, love it, love it. How are we feeling about these circle problems?
Good.
Good. Good.
I did want to ask a question about number 7.
Number 7.
Okay.
Yes.
So it says arc WU.
Mhm.
When there's only 2 points like that,
Mm.
how do you which direction are you
Is a
supposed to
good
go?
question. I feel like they made a mistake.
Uh-huh.
Because if you're not just going from one point to the next, if there's points you're going to cross through in between, you really should include one of those.
That, yeah.
Yeah. So number 7 is not a great question.
Okay.
WU, I won't give you something like that in the future. Because WU, I mean, there's W, there's U. Are we talking about WXU or WVU?
Right. Yeah.
I don't know. They didn't really tell us. Yeah, that's not a good question. I just wouldn't worry about number 7. That's not a good question. They made a mistake.
They made a mistake.
Yes, they did.
Crossing them alphabets, big marker.
Yes.
No mistake.
See, and they did it on pretty much all of the arc ones.
That's good.
Yeah.
Well,
Really a shame.
I
you like doing math, guys.
know. Okay, I'm gonna flip this to the page that's labeled 3. And let's look now at where it gets the absolute most complicated. This is the worst they'll get. The worst that they will really get. They're adding variables in.
Oh boy.
Okay.
Making us do extra math.
No. Okay, so number 11. Now I have some things happening. I want to know the measure of the arc labeled QR. So let's highlight Q and R. So QR is here.
Oh.
We're talking about
That's a T. That's okay.
I can't see it. I've done this like on 3 other ones.
Aw. Okay, QR. We're talking about an arc, not an angle. But you know, the arcs and the angles are really the same. So we're finding that. If it helps you to think of it as angles, you could also do this. Just trace that down to the center. And what I would recommend here first is I would write over to the side. I know I need to find QR. QR is labeled as -8. So I'm going to write equals -8 plus 6x. So right away, this is what I need to find. Okay, so what other angles are labeled or arcs? QU.
14.
This one is labeled 14x plus 8. Okay. So I'm going to use a different color here. That's 14x plus 8. I like that. Can we say anything else about what we have marked so far?
R and U is the diameter, which means the left side and the right side are going to both be 180.
Yes. From R to U, this is a diameter. So I know that this side of my circle, and really both sides, but this is 180 degrees total. So I'm going to highlight in a third color. This here, because of the diameter, is 180 degrees. So normally if we have those angle measures already, like let's say this was 140 and this was 40, we could say 140 plus 40 equals 180. We don't have the angle measures, but we do have values. We do have some values. I've got my -8 plus 6x, and I have 14x plus 8. Is there anything I can do with those values?
Put them together on the left side of the equation and equal it to 180.
Yes. So here's a way that we can think of this more simply. Think of this as like A, and this purple one is B. A plus B equals 180, right? Okay, we know that. Let's write that. A plus B is 180.
So would we just
We put a plus sign in there. So we can replace A and B with the values they give us, can't we?
that's what I'm talking
Yeah,
about. You just
yeah.
put them together and you solve it all together.
Perfect. So let's do that. Let's now plug in A is -8 plus 6x. So I'm going to write that. -8 plus 6x
Plus
plus,
14x plus
good, plus B, which is 14x plus 8. Equals 180. Beautiful.
seems more complicated.
Right. It seems more complicated than it is.
Just looking at it. That's-
Right. You look at it and it looks terrifying. But then you break it down and it's like, I actually think I know how to
So
do
we
this.
said, yeah, add our variables
Yes.
or subtract them, whatever.
We actually are gonna add
Yeah.
them. We're combining our like terms. So let me add another color. Okay, so we have 6x and 14x. And what do we get when we put those together? 20x. Okay. Are there any other like terms we can combine?
Negative
Same
eight.
as
Ooh,
just,
That's low.
just cancels it out.
It does. We have -8 and +8. When I add those together, I get a 0. I get 0. So you could just say they cancel. If it makes you feel a little bit better, you can write +0, but that's not going to do anything.
So you guys divided by 20?
Yes, exactly. You're right, Jacqueline. So I'll bring down my 180. And now to get x by itself, let's divide by 20.
No.
Yeah, you're right. So x
So
equals 9. Okay, so I solved for x. Do I know the measure of QR though?
Not yet.
Not yet. Not yet.
You gotta plug your 9 in to the
Bingo.
-8.
Yes, yes. Now we don't know this arc QR, but we do know that there's an x that we need to plug into, and now I know what x is. So we can take -8 plus 6 times x, replace your x with your 9. So let's see. -8 plus 6 instead of x will be 9.
probably times 9.
Yes, times 9. So, order of operations, do not add first. Do not do -8 plus 6. We always multiply first. So, let's do 6 times 9. And what do we, yes, 54. 54. Bring down my plus. This is -8 still. And what do we get?
46.
46. Good.
Hours, 46.
Yes. QR equals 46 degrees. Good job, guys.
So glad you make us circle this, because I don't think you would know what was going on.
Right, right. There's a reason we circle our answers.
Exactly.
It's because of this. Because of this. Oh, man.
And as long as
Okay.
I'm circling it, I still get what was my point.
Right, right. Oh, my goodness. Okay. Okay.
Not near as bad as what you think it might be.
Okay. And I am looking at the time. It is 2:09. I normally like to, give you a break or something around this time. But also, let me see. Thought I had some people that were going to take their quiz today. But I feel like every person in this room has done it now.
Freedom?
Okay. All right, guys. We got way further than I even expected. This is awesome. You guys are so smart, so awesome. Love you guys. Wonderful students. Have a great weekend.
You too.
Thank you. I will.